All right, we are going to be looking at another exponent rule, which is called the quotient property. Now, if you look up here, even in Delta Math, they call it dividing powers. So this is what I was talking about the other day about, I don't care, honestly, if you don't remember the names of the property. What I care is that when you look at a problem, you can look at it and say, hey, I know that I'm supposed to, here in this example, I'm supposed to subtract the exponents. Okay. Now, this property, I'm not going to lie. This rule does not encompass all the situations we're going to be dealing with. Okay. And one of the things I'm going to do today is I'm going to avoid talking about negative exponents. We're going to talk about negative exponents in a different video. Okay. And I know that may seem counterintuitive, but that's just how we approach this. Okay. All right. So before I tackle the problem that's here on my right-hand side, all right, let me just say what we're looking at here. So if I have x to the 5th over x squared, all right, so there's my example. The problem says that I can do a minus b, which means the numerator, I take the exponent that's located in the numerator and I subtract the denominator. So that is x to the 5 minus 2, which is equal to x to the 3rd. So there's my final answer. Okay, now if you remember from yesterday, I explained to you why that works. Okay, so if I take the numerator and I expand it, so I would write x 2, 3, 4, 5 times, and then on the bottom, I would have x squared, x times x. Okay, now what you have to remember, okay, you have to think about what you learned in elementary school and middle school. Okay, if I go over here and I write 5 over 5, what would you tell me the answer is? You would tell me the answer hopefully is 1. If I were to write 7 over 7, you would tell me it's 1. If I were to write a over a, pick any number I want to fill in for a, the answer is going to be 1. Okay? Now what happens is that when you multiply 1 times 1 times 1 times 1, I don't care how many ones you multiply together, the answer is always 1. Okay? All right. So I know that if I answer multiply by 1, I get 1. All right. Now, so let's look how that applies here. Okay? So if I have this x over an x and I just for a moment there put my hand and cover it up. Well, that's just a 1. I look here. That is just a 1. Okay? Well, I know what 1 times 1 is. Well, 1 times 1 is 1. Okay? So now I'm left with these x's right here. So that's x to the 3rd, right? Okay? Because if I were to rewrite this using my exponent rules, that'd be x to the 3rd. Well, if I take x to the 3rd and I multiply by 1, well, I just have x to the 3rd because now I'm multiplying by 1, which means there's no change. Okay? All right? So that is equal to x to the 3rd. So that's why the rule works. It's because when these become a 1, it doesn't change anything because 1 times 1 is 1. And then now, since I've got that taken care of, if I multiply this by 1, well, I just get this back. Okay. All right. Now this is where you're going to be like, oh, this is not fair. Okay. All right. If I had x squared over x to the 5th, okay? If I do 2 minus 5, okay, and I'm not even going to write it down, okay, because I don't even want you to write it, but I want you to think about it. If I were to write 2 minus 5, that's going to equal -3, okay? And that is going to present a problem in all of these problems that Delta Math is giving you, because if you look at the directions here on Delta Math, it says fully simplify using only positive exponents. So that means I can't have -3. So how do I combat that? Okay, well, I actually use that rule, but I use it backwards. Now, let me show you the long way. And then probably after I explain it the long way, most of you will be fine with the approach I'm taking. All right, so x squared, well, that's x times x. All right, x to the 5th. I'll write it out 5 times. Equals. All right, well, just like this, we have some canceling. So those are gone, okay, because they equal 1, okay? But now look at the difference, okay? Let me scroll my paper back down here, okay? Look at the difference really closely, okay? These x's right here were left in the numerator. These x's right here have been left in the denominator. All right, I cannot leave this problem like this and say, okay, that's my final answer, okay? When you have a fraction, you have to have both a numerator and a denominator. Well, this is why this concept right here of this 1 comes into play, okay? Because really, I have 1 times 1. 1. That is my final answer. Okay, and this is where it would be so much easier or so much better if I had you in front of me face to face, because somebody in the room would be able to tell me, what do I do if I were given this problem from the beginning? Well, hopefully somebody is already thinking it and they would say, well, why not just do 5 minus 2? Okay, so start at the bottom, 5 minus 2, and just write x to the 3rd in the denominator. Okay, and that's exactly what you're going to do. Okay, so before, we haven't even gotten to the delta math problem yet. All right, so let's try 2 examples, okay, where it's just pretty straightforward. So I have x to the 8th over x to the 10th. And then I'm going to have x to the 12 over x to the 7. Okay? All right. So now this is what I do when I have problems and I'm trying to say, okay, I don't know which way I need to subtract. Okay. Subtract when you don't subtract. When you look at a problem, circle the exponent that's bigger. Okay, so since the exponent is bigger, look where I circled it. I circled it and it's in the denominator. So that means when I subtract, my answer goes in the denominator. It also tells me where to start my subtraction. So that means I'm going to go 10 minus 2. And because I circled this, my x will go here, and 10 minus 8, I think I said 10 minus 2 because I said the answer. 10 minus 8 is 2. And then I'm just going to put a 1 there. All right, same thing here. I'm going to circle the larger exponent. Okay, so that's 12. So that means I'm going to subtract 12 minus 7, but that means my answer would go in the numerator. Okay, so x, well, 12 minus 7, that's 5. And if we were being consistent, I'd put a 1 here, but when you divide by 1, it's just x to the 5th. Okay? All right, so now let's look at the problem we've got here on Desmos, or delta math, I'm sorry. So 25, x to the 3rd, y to the 3rd, over 15, x to the 7th, y, equals. All right. Now, when I do these problems, that's exactly what I do. I automatically put a fraction, okay? That fraction bar there. Okay. All right, now 25 over 15. So we're just pretend the variables are not there, okay? 25 over 15, I need to simplify that. So just like I would a fraction with numbers back in elementary school and middle school. All right, I'm going to divide the top and the bottom by 5, okay? Because that's what I would use to simplify it. So 25 divided by 5 is 5. 15 divided by 5 is 3. All right, So that's that part. All right, now I'm going to look at the x, and I'm going to circle the larger exponent. So that's here. I'm going to look at the y's. Okay, remember there's an exponent of 1 here. If I don't write it down, there's an understood 1. All right, and so I'm going to circle the larger exponent. Okay, so now the reason I've done this is because when I look at my final answer, there should be a y up here. Okay, because that's where I've got my y, and there's going to be an x. I already know there's going to be an x on the bottom. Okay, now I just have to subtract. So 7 minus 3, 4. 3 minus 1, 2. All right, now let's talk about typing it in. Okay, so if I go over here, if I type in the division sign first, okay, so that /, that's going to give me that fraction, that numerator, and that denominator. So I'm going to do 5y squared. Then on the bottom, 3x to the 4th. Submit my answer. Yes. Got my green check. All right. Let's try another one. Okay. All right. So 18, x to the 6th, y to the 8th, over 12, x squared, y to the 8th. Okay? Equals, and then a fraction bar. All right. So same thing. I'm going to ignore the variables first. Okay? So just cover them up. Don't even look at them. All right, now I need to take 18 over 12 and I need to simplify it, okay? So I need to divide the top number and the bottom number by the largest number possible, okay? So I can divide 18 and 12 by 6, all right? So 18 divided by 6, 3, 12 divided by 6, 2, okay? All right. Now I've got my x's, okay, and my larger exponent is on the top. Okay, now look here. My exponents are equal. Okay, so I have the same value on the top and I have the same value on the bottom. They eliminate. So if you have the same variable with the same exponent, they eliminate. Okay, so they eliminate. Okay, and it's only these, okay, because they had the same there was the same exponent and the same variable. All right, so that means my problem is only going to have an x, and it's going to be here in the numerator because that's the one I circled. Okay, so 6 minus 2, 4. All right, so I'm going to go over here. I'm going to type the division symbol first, so I get my fraction. I'm going to type 3x to the 4th, and then on the denominator, or in the denominator, 2. Submit my answer. Yes. There we go. Okay. All right. All right. I'm just checking to make sure. All right. Let's do one more problem. Okay. All right. Now this time I'm not going to write anything down because I think some of you guys could do it without writing it down. So I'm going to put the division sign. Okay. All right. I've got 14 over 21. So that means I can divide the 14 and 21 by the biggest number possible, so that's 7. So 14 divided by 7 is 2, and then 21 divided by 7 is 3. Okay, so I've done that step. Okay, all right, now I have x to the 3rd on top and I have x to the 8th on the bottom, so that means 8 is bigger. So if I move my arrow key, x is going to be on the bottom and 8 minus 3 is 5. So shift 6, 5. All right, now I've got to do my y values. Okay, so I have 6 on top, I have a 1 on the bottom. So 6 minus 1. So y to the 5th. Submit my answer. Yes, we got it. Okay. All right. And then he shows you an alternate approach as well. And he's really just breaking it down into 3 separate problems and then putting it back together. Okay. All right. So if you need additional assistance, let me know. If you need more examples, shoot me a question on Remind or email. Make sure you send me a picture of the problem you're looking at, and I can shoot you back a picture with some work that I've done, or I can make a quick video, whatever is going to help you, okay? Because honestly, you guys, the problem doesn't change, okay? You are just going to subtract these exponents. And really, probably for some of you, the hardest part will be reducing the numbers. So like taking this 18 over 12, and so I don't like to use the word reduce, simplifying, okay? Simplifying these fractions, okay? Because if you've noticed, I have not referenced a calculator, and I've not referenced a calculator on how to simplify fractions, okay? All right, good luck.